Hello everyone and welcome to Ask Tom Database Security for November 2020. I'm Russ Lowenthal, Product Manager for Database Security, and today's topic is really a basic one. We're going to be talking about database passwords. We'll take you through what passwords are, how to make complex passwords, how to protect passwords, everything you need to know about managing passwords in the Oracle database. Just a reminder that these calls are recorded, and I'll usually have the recording up on the Ask Tom website within a couple of days after the session. We do 2 of these sessions on the second Thursday of each month, and the idea behind that is hopefully we're going to have one of these sessions that is at a time that you can attend live, so you can ask questions if you want to. But if none of these times work for you, you're always welcome to view the recordings. As we go through the session, please do enter any questions into the Q&A applet. You'll see the button to open the panel at the bottom of your screen. You're not limited to just today's topic. You can ask questions really about anything as we go along, anything about database security, and I'll do my best to answer. If I don't know the answer, then I'll set up a way to talk to you later and find out what the answer is. Before we get into the technical topic, just a few announcements. The first one is the October 2020 quarterly patch is now available. That brings, if you're using 19C, the database version up to 19.9 after you've installed that patch. Coincidentally, there are 19 security fixes in this quarter's patch update. The highest severity is an 8.8, and this one's a little bit unusual. This quarterly patch does impact the Oracle client, so you'll be applying it both on the database server side and on the client side. I've got the Moss note with information on patch numbers below here on the screen. Please take a look at that and start planning your patching cycle as whatever your corporate guidelines are. Another update is on DataSafe. We have 2 things to announce this month. The first one is that the limited availability program for the on-premises connector is drawing to a close. We will stop accepting applications for new members in the program on the 20th of this month. That's next Friday. And we'll stop the program altogether on the 30th of this month. That means that if you have a database registered with DataSafe using the on-premises connector under the limited availability program, that's been free up until now. You need to deregister that database before the 30th, because on the 30th, when we switch to general availability, those will become paid usage rather than free. If you do still have a few weeks if you want to play with this. If you're interested, you can still apply for the limited availability program. I've got the Moss note here on the screen. It will be generally available on the 1st of December. And just a quick, thank you to everyone who participated in this limited availability program. We got really good feedback, and the information that we got from you during the limited availability period has made this connector really, really solid. We're moving into general availability with a very mature product now. Also on the 1st of December, DataSafe will begin supporting 11.2.04 databases. Here again, we've been in limited availability with this for a while. We're moving it to general availability, so anyone can register an 11G database, 11.204 database. There is one component of DataSafe that does not work for 11G databases, and that is the ability to provision new audit policies. DataSafe's audit policy provisioning is based on unified audit, which doesn't exist in 11G. That was a 12C new feature, so of course you can't use that. But everything else works. Sensitive data discovery, data masking, user assessment, security assessment, audit collection. We can collect from the traditional audit trail. We just can't provision audit policies. That has to be done within the database. Also like to let you know about an update to Audit Vault and Database Firewall 20. This week we released the first major patch for that, so release update 2 is now available. You can either download a complete new installation from the Oracle Delivery Cloud, eDelivery, or you can download a patch to upgrade it from My Oracle Support, and I have the patch here on the screen. With the release of this, the early adopter program for Audit Vault and Database Firewall 20 is now ended. We've got the first major patch set out. Again, huge thanks to the many people who participated in this program. This release update fixes over 60 issues that were identified during the early adopter program, which means that as you're beginning to adopt or apply, use Audit Vault and Database Firewall 20.2, here again the maturity of the product, even just with a single bundle patch, has really increased greatly. Can't thank those of you who helped us during our early adopter program enough, and we look forward to having you stay with us on 20.2. There's some other things in 20.2 besides just the fixes. We support audit collection from Microsoft Server 2019, and that is for install of Audit Agent, install of Host Monitor, and audit collection from the event log on the Microsoft servers. We also support the DB2 instance level audit for IBM DB2. We've made a change to how we work with multi-tenant in 20.2. In 20.1, we introduced the ability to collect audit data at the CDB level for all pluggable databases. However, all of the pluggables had to be open. If even one pluggable was not in an open state, 20.1 wouldn't collect at the container level. In 20.2, we can now collect from all open pluggables and just ignore the ones that are closed. And again, this is feedback from the early adopter program. We made some improvements to high availability support. We now allow agents to be associated with multiple host IP addresses. This is important in really two use cases. One is where you've got a server that has multiple network interface cards, dual NICs or 3 or 4. Now you can fail over between NICs. It's also important if you have a server cluster where you have multiple servers that are hosting one application, one database. Windows Server Clustering is an example of this. With multiple IP addresses, you can now fail over from one server to another, and as long as you start the agent up on that new server, it'll just keep going with the new IP address. You don't have to do anything to it. So if you're using server clusters, you'll want to include restarts of the agent as you fail over. That's mostly what's in this patch. There's a little bit more in there. If you take a look at the What's New section in the Audit Vault and Database Firewall Administrator's Guide, you'll see full details on all of this. Last announcements before we get to today's topic is Oracle Live Labs. I've got the URL for this on the screen here. Oracle Live Labs gives you a way to test Oracle technology out without having to do a lot of installs yourself and configuration. We have labs on all the topics you see here on the bottom of the screen, and I just want to let you know we've been working on this for months, getting these labs in shape. And labs on data safe, transparent data encryption, unified auditing, and this is just the start. We intend to keep adding to this because there's a lot more to security than what you see here. But different labs will have different ways you can run them. Some of the labs you can run in your own tenancy. Some of the labs you can run even in a trial account. There'll be labs that will allow you to run in our tenancy, so we'll spin up an image for you. But again, the idea is to let you get hands-on in a guided fashion with database security. It's a great way to upskill if you're maybe looking at a security topic that you haven't played around with before. To get to the labs, you go to that bit.ly go live labs URL that I had on the previous screen. When you come into the UI, if you will filter on focus area security and choose Data Safe and Database 19C as your products. And you'll see all of the labs here. Right now there's 11 of them. We'll be expanding this, like I said. But just click into any lab. You'll see full details on how to set it up, what your options are for running it. And as you go into it, it's guided step by step. Really a great resource for you to learn database security. And as promised, that is the last announcement. Let's go ahead and get to today's topic, which is database passwords. Now, database allows 4 different authentication options. There's username and password, which is today's topic, Kerberos, certificate, and radius. We talked about Kerberos, I guess it was this summer. So several months ago, we talked about Kerberos, And it's funny, we were discussing ourselves what this month's topic was going to be, and it kind of hit us. Well, we've talked about Kerberos, but we never talked about username and password. And username and password is really the most common way to authenticate to an Oracle database. And by most common, I don't mean like 50% or 51% of databases use username and password. 85 to 90% of databases still use username and password for logins. Kerberos is the second most common. It's really increasing in popularity. A lot of that is driven by integration with Active Directory as more people are adopting 18C and 19C with the new centrally managed user feature. We see more and more people moving to Kerberos authentication. So if username and password is 85% of the logins that are out there, Kerberos is probably 12%. The remainder are split between certificate and radius. Certificate authentication, usually a special purpose, a lot of times used for application logins where you want to have a persistent login token and not depend on username password. Certificate authentication is done as part of TLS encryption. The fourth option is radius. This is very rare, less than 1%, maybe 1.5% if we're lucky there, but it is growing in popularity. Radius is how most of us will get to strong authentication or multi-factor authentication, and most multi-factor authentication implementations do use Radius. So you could be using Oracle's own Identity Cloud Service or Okta or RSA Secure ID or YubiKey. I mean, most multi-factor systems will work with Radius. Okay, but today's topic, passwords. Now, we're going to hit three main areas today. We're going to talk about controlling the strength of your password. We're going to talk about how we store passwords using what we call password verifiers, which are hashed representations of passwords. I'll talk more about that if you don't know what hashing is later. And we'll talk about how to change passwords and create users securely. Let's dig into strength of the password, which is primarily controlled by user profiles. User profiles are just named collections of policy restrictions. Every database user is assigned a profile. You can only have one profile for a user, but different users can have different profiles. So a single database could have many different ways that we're enforcing strength or for passwords. There are 8 parameters in a profile that control password strength. Let's just run through these quickly. First one is inactive account time. If you have a database account that doesn't log in for the number of days specified in inactive account time, that account will lock. The idea here is if you have dormant users, this is a really good way to attack a database. You maybe get someone who's left the company, you haven't gotten around to deleting their account. Well, if they leave and just happen to give up their password after they leave, or maybe someone compromises their laptop or something and that's still on there, then that would be a point of attack for you. So inactive account time mitigates that by saying after this number of days, if you haven't logged in, you can't log in. I have to go in and unlock your account. Password verify function is a PL/SQL function that will check new passwords and apply complexity rules to that. We'll talk more about password verify functions here in just a little bit. Failed login attempts are exactly what it sounds like. If I try to log into a database and I fail, and I try again and I fail, and I try again and I fail, when I reach the number of times specified in failed login attempts, I can't try anymore. My account will lock. And that account will lock for the length of password lock time. By default, that's 1 day. So I've locked my account. After 1 day, my account automatically unlocks and I can begin trying to log in again. Password lifetime, pretty simple concept. It's when I change my password, how long before I have to change it again? How long before the password expires? When the password expires, password grace time tells me how long do I have before the password or before the account locks. And the idea here is you start getting warnings, you need to change your password, you need to change your password. Okay, now your password's expired, you're in your grace time. If you don't change it within this number of days, you're done. You'll have to get a DBA or somebody to unlock your account. Password reuse max and reuse time, again, exactly what it sounds like. You may not want users to be able to reuse a password they've used before. You want every password to be unique. Reuse max says how many password changes before you can reuse a password. Reuse time says how long before a password can be reused. So you can control this in two different ways, or both ways. You can use both of them if you want to. There's another thing that controls password strength, and that's an initialization parameter called sec case sensitive login. We introduced this parameter in 11GR1. Before 11GR1, passwords were not, Oracle database passwords were not case sensitive. It didn't matter whether you entered, uppercase, lowercase, or all uppercase or all lowercase. Passwords was just the string that it was kind of forced to uppercase. Remember 10G, that was 2005. It was a kinder, gentler world back then. But even by 2005, we really were starting to want case-sensitive passwords. So in 2007, when we came out with 11GR1, we introduced case-sensitive passwords. And that greatly improves the strength of your passwords. But there are some users or some places where you couldn't afford to use case-sensitive passwords. Maybe you had older clients. Maybe you had applications that expected the passwords to be case-insensitive. So we gave you a parameter where you could turn off case sensitivity. This parameter is now deprecated. If you still have it set in 19C, it's going away very, very soon. But you can still use set case sensitive login to turn password sensitivity off. We definitely don't recommend that. I said I'd come back to password complexity functions. A password verification function, a password complexity function, is just a PL SQL function that is called whenever a password is changed. We can check anything that we want during this complexity function. We ship with 4 different password functions in 19C. And they check things like, what is the length of the password? Does the password have special characters, uppercase, lowercase? Does it use common words? That type of things, typical password complexity checks. One of these is kind of a special case, the Aura12C STIG verify function. We work a lot with the Defense Information Systems Agency, DISA's, Secure Technical Implementation Guides, STIGs. The STIGs do update as rules change. The password complexity requirements of the STIG also change. If you use the Aura12C STIG verify function, when those rules change, we will update our policy, which the next time you patch your database will update your verify function so you stay current with the STIG. We do allow you to create custom functions, and we even give you an example. If you look in Oracle Home RDBMS admin, there's a script called catpvf.sql. You can grab the content of this script, create your own, and customize the password verification function to meet your needs. All right. If your password profiles don't follow what would normally be considered best practices, as we assess database security, and it doesn't matter whether you're using DataSafe, which is what I'm showing here, or DBSAT, we will have a finding that says, you've got issues here. Notice that we look for things like you don't have a limitation on the number of failed login attempts, which exposes you to brute force attacks, or maybe you're missing password verification functions. This would violate both the CIS benchmarks and the DISA STIGs. That's why you see in the upper right-hand corners of the finding CIS and STIG. But we will highlight issues with your password profiles during assessment. I'm often asked, what do I recommend for password profiles? This is my starting point. Obviously, you're going to adjust your password profiles to meet your needs, but here's what I usually start with. If you haven't logged into the database within 30 days, I normally want to lock your account, because after 30 days, if you're not using your account, then probably it's not going to be that much of a burden on you to come see me and I can unlock your account. For a verify function, I'll pick the Aura12C strong verify function. Just by default. This does meet the current DISA STIG requirements, but it doesn't automatically update so things don't change on me during patches. But it's a very good up-to-date password standard. For failed login attempts, if it's interactive accounts, human users doing stuff, I'll normally fail after 5 tries. If you can't get your password right in 5 tries, we'll lock your account, and then you can come see me, and we'll talk about how to do this better. For non-interactive accounts, service accounts, like maybe application accounts, those shouldn't be getting failed logins. So I'll set it to 3, maybe even 2, because the only reason why a service account should lock is either because someone is using it outside of the service, right? Because the service has the credentials hard-coded into it, or it's retrieving the credentials via API, but it's not typing in the password. It's not making mistakes. So if that account locks because of failed logins, it's because an interactive login was used with that service account, which would violate my policy normally. So, I want to know when that happens. For password lock time, for human users, I will normally set it to 1 hour. Now, the unit of measurement for password lock time is days, but if I do, there's a 1,440 minutes in a day if I do 60 over 1440, or I can reduce that fraction if I want to. That will lock it for 1 hour. For service accounts, I'll do 1 day because I don't really want people using service accounts. And if they are doing it, I want that just to absolutely not be allowed. The idea behind password lock time is to slow down a brute force attack. If I lock an interactive account for an hour, then a password cracker that's going through 5 tries lock for an hour, 5 tries lock for an hour, it's going to take a very long time to crack an account. For password lifetime, for interactive accounts, I'll set it to 90 days. For non-interactive accounts, I'll normally set it to unlimited. In other words, the passwords never expire. And that obviously introduces risk because the passwords aren't expiring, but I will mitigate that risk using Database Vault. And I'll use Database Vault to do things like say this account can only be used from these IP addresses, only using these programs. The idea here is to control the ability of someone to use this account interactively. We'll audit the use of this account. And the reason I set it to unlimited is I don't want to expire a password and break an application. I would much rather change these passwords on my schedule rather than have the database schedule expire an account and break something. Password grace time, I normally go to 7 days, and for reuse, 20 passwords, 365 days. Here again, if you look at the bottom of the screen, there is a passwords profile script in RDBMS admin called utilpwd.sql. This gives you a great example of creating password profiles. If you look in the script, there's some comments in there with different password profile suggestions that you might be interested in looking at. Don't edit this script, but you can create your own copy of this script and update as you want to. That's it for password strength. I want to shift to password storage next. But before I do that, there's 2 terms that I need to make sure you know. The first one is cryptographic hashing. Now, hashing is not encryption. Encryption is 2-way. I encrypt something and I decrypt something, like transparent data encryption or network encryption. It's decrypted, or it's encrypted and then decrypted later on. Hashing is 1-way. I run something through a mathematical algorithm that receives a certain input, and it hashes that, applies a cryptographic algorithm to hash it, and it spits out a unique value, which according to Wikipedia should be practically infeasible to invert. In other words, I can't take a hash and from the hash figure out what the initial value was. Hashing is very commonly used for passwords. You've almost certainly used hashing algorithms, even if you didn't realize that's what you were doing, if you've ever downloaded software from the Oracle Delivery Cloud. When you download something from eDelivery, there's always a chance that during download something gets corrupt. So after that's happened to you a couple of times, you usually pay attention to those MD5 sums and SHA-1 sums that we display in eDelivery, and you'll run an MD5 sum to check your downloaded file against the hashed value that's up there on eDelivery. It's a 1-way function that gives you, something to check against. Another concept that you need to be aware of is a cryptographic salt. Now, this isn't the stuff you sprinkle on food. A cryptographic salt is random data that gets added during a hashing operation. And the reason that we're doing this is if I hash the password Oracle, I don't want every time I hash the password Oracle for it to spit out the same value. I want each one to be unique so that if I have two users that have the same password, which is always possible, the hashes don't look the same. Now, the reason for this is someone who's just looking at the hashes can't tell that there's two that are the same, but also someone who has managed to steal your hashes, more on that later, can't just do an offline attack using something called a rainbow table, just a bunch of pre-computed hashes, to easily figure out what your hashed value is. So we've talked about hashing and salting. Now let's talk about how we store passwords. Oracle Database stores passwords as something called a password verifier. A password verifier is a hashed representation of the password. As time has progressed, hashing algorithms have gotten stronger and stronger. And as hashing algorithms have gotten stronger and stronger, Oracle Database adopts stronger standards. So if you're using Oracle 10G, those passwords were hashed using MD5. By today's standards, MD5 is a fairly insecure hashing algorithm. But back in 2005, or back in 2003, when 10G was first introduced, MD5 was a perfectly good. It was the standard. Everyone used MD5. By the time we got to 11G, MD5, people weren't really recommending it anymore, so we switched to SHA-1, and we began using a salt to help prevent collisions with the equal, to help make it harder to attack the password. By the time we got to 12C, especially 12.102, we switched right in that first bundle patch came out for 12.1. We switched from SHA-1 to SHA-512, and we switched to a multi-round password key derivation function. That's what PBKDF2 means, to increase the difficulty of attacking the password even more. That is still the current state of the art. SHA-512 multi-round PPK-DF2 is still what we consider to be the state of the art for password hashing algorithms. But as we move on past 19C into 21, 22, 23, sooner or later we'll probably change this again and adopt a new standard. For storage of passwords, MD5 passwords, those were stored in the password field in sys.user $. The SHA-1 and SHA-512 hashes are also stored in sys.user $, but they're stored in the spare for column. Let's take a quick look at this. So if I were to go out and say that I want to select username spare for from sys.user $, where username equals, there's no column called username in sys.user $, it's just name. And we can see that we have in spare for a hash that starts with an S colon. That's a tag that indicates this is my SHA-1 hash, and a hash that starts with a T. This is my SHA-512 hash. So multiple hashes for the same user. This is something that is perfectly normal. We can store more than one verifier, the same password hash, different ways. And the reason we do this is for backwards compatibility with older database clients. If I were using an 11G database to connect to my an 11G client to connect to my 19C database, then I would need to have a password verifier that client can understand. We control this behavior, this creation of multiple hashes, with a parameter from the SQLnet.aura file. It's SQLnet.allowedLoginVersionServer. And what we do is we have three different values we can set here. If I set it to 8, which we do not recommend, then what I'm creating is old 10G MD5 hashes, 11G hashes, and 12C hashes. If I set it to 12, which is the default, then I create 11G and 12C hashes only. If I set it to 12A, I create only the 12C hashes. So that would mean that an 11G client wouldn't be able to connect if I were set to 12A. If I'm still using case-insensitive passwords, I have to have 8 because only MD5 allows case insensitivity. We don't allow that with the 11G and 12C. But this is this is how you control which hashes will be created when a user creates their passwords. Now, speaking of backward compatibility, if you are using XMLDB and if you're using HTTP digest authentication, this also produces an MD5 verifier, which will also be stored in the spare4 column. Digest authentication was there's still some applications that use digest authentication, is an attempt to make HTTP authentication more secure than the default. So without digest authentication, if you're just using basic authentication, then the client just sends username and password to whatever the server is, and the server checks that. With digest authentication, there are a couple of rounds there. The client connects the server sends the client something called a nonce. It's almost like an encryption key. The client encrypts the password with that encryption key and sends that encrypted digest to the server for processing. HTTP digest, commonly used protocol. We supported that with XMLDB. In fact, it was turned on by default in your 11G databases and in 12.1, but we disable that by default 12.2 and higher. If you have a database that has been around for a while, you may have passwords that were migrated from 11 to 12.1 to 12.2 all the way up to 19C, and if they haven't been changed, then you could still have HTTP verifiers out there. If someone gains access to those, then they're just MD5. They're relatively easy to crack. So let me show you what this looks like here. By default, there are no HTTP verifiers. So what I'm going to do is I'm going to alter user DBA Deborah, and I'm going to say digest enable. Now, when I change the password for this user, and I go back and I look at my digest again, what I can see is I have my SHA-1 hash, I have my, where's the T? I have my SHA-512 hash, but I also have a new hash. And notice how short this hash value is. This is an MD5 hash. Horribly insecure, shouldn't be doing that. So what I would want to do is if I see a hash like that, which I could look at a couple of different ways. I could just look at spare4 and user $, or if I were to select password underscore versions from DBA underscore users, where username, then I can see there's an HTTP verifier there. If I find an HTTP verifier, then all I have to do to get rid of it is alter user. And now when I look, there is no HTTP verifier. And if I go check spare4, that HTTP verifier is gone. Okay? So if you have HTTP verifiers in your database, when you do an assessment, we will most definitely tell you we found these things. And again, doesn't matter if you're using DBSat or DataSafe, if we find an HTTP verifier, we consider this to be a high risk because MD5 passwords or MD5 hashes are so easy to break, and we will strongly recommend that you remove them. If you are still using XMLDB with HTTP digest authentication, which we still support for backwards compatibility, then you need to put some mitigating controls on this account. Like you should be auditing every login and looking every login for this account and making sure you're aware when someone logs in from anywhere else. You probably want to be auditing what this account is doing as well. Again, to check for it, look for HTTP verifiers in password versions and DBA users, or if you really want to get down in the weeds, you can look at SPARE4 and the user $sign and look for something that has that H tag in front of it. Speaking of selecting from user $sign, you really shouldn't be able to do that if you're a normal database user. No one should be able to select from stored password hashes casually, because if I can extract the password hashes from the database, I can do an offline attack against those hashes. SHA-1, SHA-512, relatively secure, but still possible to break given enough time and effort. And if I have, a botnet of a couple of thousand servers out there, and I want to put that botnet out there to generating hashes and trying to create collisions, even a salted hash, if I understand the salting algorithm, which you can figure out given enough time and effort, you can produce a collision and get a password that'll work. So again, if you're doing an assessment and we find that there are users who have access to password hashes, we will alert on that, both DBSat and DataSafe. Okay. Let's talk a little bit about protecting passwords during login. And this is one of my favorite security things because I don't have to do anything. Oracle just does it for me. When a client logs into an Oracle database, we don't actually send the password to the database. Here's what really happens in the background. Client logs in and it sends the username to the database along with what hashing capabilities are supported by the client. Is it an 11G client, 12C higher client, 10G client? Okay. The database looks at that and it creates a session token. This is unique for every session. It then encrypts that session token using the strongest hashing algorithm that is supported by both the database and the client. It also generates a random salt, and it sends that random salt and the session token back to the client. The client, now we're on number 3, by the way. The client receives that password, or the client receives that salt, and it receives that session token, and it generates a password hash using the salt provided by the database and the password that the user gave when they logged in. We then decrypt the server session token using that hash, generate our own session token, and encrypt that session token with the server token and a hash of the password that was given to us. We send that to the database server where we validate it using the stored password hash that's in the database, the one that's in SPARE4, and the server session token, and that completes our authentication request. So not only do we not send clear text passwords over the network, we don't even send clear text hashes over the next network. We encrypt the hash before we send it. What this means is that the chances of someone intercepting your login during a database login attempt and figuring out what your password is are extraordinarily low. Nation state type means would even then might not be able to do it, but I hesitate to say anything's impossible. But it certainly is not trivial. There are times, however, when it is trivial to intercept a password over the network. And I want to show you one of those times right now. So what I'm going to do is I am going to do a network sniffing attack. I happen to be logged into the database server here, and I'm lazy, so I'm going to run the command TCP dump. But for those of you who know it, what I'm doing in the background is I'm actually running this command. My database listener's on port 1522. So I'll run TCP dump. See, I can't even type TCP dump. And I'm going to send the output of that to a file. Okay, so I'm now capturing everything that's coming in over the network, and I am going to change a password in an insecure fashion. You should never do this over an unencrypted network channel. But what I'm going to do is I'm going to say alter user DBA Deborah identified by, and let's give her a password of look at me. Okay, let's go stop our network sniffing attack, and let's take a look at what we captured. All right, so if we look at this, do we see look at me somewhere? Why, look at that. Alter user DBA Deborah identified by look at me. If you change a password using alter user identified by, that is sent over the network just the way you typed it. Let's get out of here, and we're going to set up our TCP dump again. But this time we'll send it to test 2. And now we're going to change the password in a secure fashion. So we'll say password DBA Deborah. Okay, the password for DBA Deborah is now changed. Let's see what we captured. Do we see look at me? No, we don't. Let's take a look at DBA Deborah. Here is my password changed. For the user DBA Deborah, we have created a new password. This is the password that was created. But it wasn't sent in clear text. It was sent in encrypted form. So this is the secure way to send a password. So again, when you change a user's password, if you're not using an encrypted network connection, then you should never say alter user username identified by password. You should instead use the password command. If you are using an encrypted network connection, that could be native network encryption or TLS, then this doesn't matter because it's everything's encrypted. If you're using a bequeath connection, you have a local session to the database server and you say connect / as sysdba or connect with a locally authenticated DBA account, then again, not going over the network, this doesn't matter. But if you are going over an unencrypted network connection and you've ever said alter user username identified by password, everyone could know your password. Anyone who has access to that network segment can know your password. Okay? There's another case where passwords can be exposed in clear text. Okay, let's just go back over to here, and I'm going to create user Joe identified by but I'm not going to hit enter here because I want to start my my little sniffing attack first. All right, so we're capturing our network. We'll enter our command. We'll say stop. And let's take a look at test 3. And here again, there's the password. So the right way to create a user is not create user identified by the username and password. It's instead to say create user and just give it a username. And then use the password command. That would look something like this. Oops, wrong session. Here we go. So I'm just going to do create user Joe. And now I will say password Joe. Try that again. And my password has changed. And as we've already seen, this methodology does not send a password over the network. Okay. Now, this ability to create a user with no password, that was a new feature in 18C, passwordless users. If you are using an older version of the database, here's what you do. Create user, username, identified externally. No password was ever sent this way. Then use the password command to change that user's password, and you'll now have a password authenticated user. Okay. So this is how you create a user securely. That's really it for passwords today. We've talked about just about everything with passwords. I didn't cover database password files. These are used for remote login as sysdba or sysopera or something like that. But other than that, hopefully you've got a good feeling now for how to control the strength of your passwords with password profiles, how we store passwords, and how you can control what hashing algorithms are used during storage. We talked about the evil HTTP password verifiers and how to remove them from your database. And we talked about secure ways to change passwords and create database users. Thank you for giving me some time today. Next month, second Thursday, is the 10th of December, and I can't tell you what the topic is going to be because it's a secret. I can tell you that there's a nice little announcement coming later this month. If you are subscribed to the Ask Tom database security sessions, and please do if you're not already, you'll get a note when I update that website as soon as I'm allowed to tell you what the topic is going to be next month. But really looking forward to it. For those of you that celebrate a holiday during December, this is like just an early present for that. But I hope to see you next month. I'm really looking forward to talking about this session. And again, thanks for giving me your time today, and hope to see you next month.